Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be looking at transformations of linear functions. This is part one of a two-part lesson. The simplest form of a function family is called the parent function. The linear parent function is shown below. Use the graph of the linear function to answer the questions. So the first question is what is the slope of the linear parent function? So I can see this parent function passes through 0, 0. And if I pick another friendly point, say right here, I'm going up 2 over 2, which would reduce to 1. So I know the slope of my linear parent function is positive 1. The next question is what is the y-intercept of the linear parent function? Well, the linear parent function passes through the point 0, 0, so I know that b is 0. So if I was asked to write an equation for f of x, I would have f of x equals 1x plus 0. But really, all I need to write is the x. It's understood that the slope is 1, and it's understood that the y-intercept is 0. So the linear parent function can be transformed by adding or subtracting numbers to the function or to the input values. In other words, we could move this linear parent function to the left, to the right. We could move it up the y-axis, down the y-axis, simply by adding or subtracting numbers, either to the function itself or to the input values. Let's start by looking at what happens when we add or subtract numbers to the function. So if we have f of x plus d, in other words, f of x plus some constant like f of x plus 8, f of x plus 12, the graph will move up the y-axis. If we have f of x minus d, the graph will move down the y-axis. So only the y values are being changed here. So in example 1, it said describe how the functions relate to the parent function f of x equals x, and then graph and label the functions h of x and g of x. So in example A, we have g of x is equal to f of x plus 3. Now here's what that means. You're going to take your function values and add 3 to each one. So what I'm going to do is I'm going to make a table for x and f of x of my parent function. And I'm just going to pick 3 random points off of my parent function. So I'll use this one, and this one. Okay, so we have negative 2, 0, 0, and positive 2, 2. I could pick more, but we only really need 3 to demonstrate what's going to happen here. Now I'm going to make a new table, and my new table is going to be x and f of x plus 3, which this means that the x values will stay the same, negative 2, 0, 2, but I'm going to add 3 to each f of x value. So in other words, I'm going to take my first f of x value, negative 2, and I'm going to add 3 to that. And when I do, negative 2 plus 3 would be positive 1. Then I'm going to take my next f of x value, which is 0, and add 3 to that. So 0 plus 3 would be 3. And then I'll take my final f of x value, 2, and add 3 to that, which would give me 5. Now, I'm going to plot this new function, g of x. Let me change pen color, so let's put it in pink. So, negative 2, 1, 0, 3, and 2, 5. So notice each one of these dots moved up 3 units. Oh, that line does not look good. Let me try that one more time. Something like that. It wanted me to label it. It asked you to describe in words how this function changed. So f of x shifted up 3 units. Okay. Now we're going to make a second function, h of x, and now we're going to subtract 4 from the function values. So again, I'm going to start here with my original table, x and f of x. We're still using the parent function here, so I still want to use the points off my original function, the dashed line. But this time, I'm going to take the f of x and subtract 4 from each f of x value. So my x values don't change, but I'm going to subtract 4 from each x value. So I'll start here, -2, and subtract 4, and that would give me -6. Then I'll go to my next f of x value, which is 0, and subtract 4, which that will give me -4. And then go to my final f of x value, 2, and subtract 4, so that would give me -2. Now let's graph this and say red. So -2, 1, 2, 3, 4, 5, 6, 0, -4, and 2, -2. So in this example, each point shifted down the y-axis, and they wanted us to label this function h of x. So each f of x value just shifted down 4 units. Example 2. 2 students transformed the equation f of x equals x as shown below. Use the graph to answer the question. Question A. Marissa graphed g of x is equal to f of x plus 6. Label Marissa's line g of x. Well, we have to decide which line is Marissa's line. But what we know is they added 6 to the original function. The original function is the dashed line. So if they added 6 to the original function, that means it moved up 6 units. So that means this top line must be g of x. All right. Josh graphed the second line. Label Josh's line h of x. So if the top line was g of x, we know that Josh's line must be the bottom line. We'll label that h of x. So what is the value of d? In other words, how many units did that graph shift down? So if I compare the y-intercept of my parent function is at 0, 0. How many did this move down the y-axis? So 1, 2, 3, 4, 5, 6, 7, 8. It moved down 8 units, which means the value of d is -8. Now, we want to write an equation to describe Josh's line in terms of f of x. So Josh's line is labeled h of x. And Josh's line could be obtained by taking f of x and subtracting 8 units from it. All right. Now, in our first 2 examples, we looked at changing the y values. When we change the y values of our functions, the graph moved up the y-axis or down the y-axis. In our next set of examples, we're going to be changing the x values or the input values. So, effects of changing c on the graph of f of x minus c. So, if I have my constant here is in parentheses, that means we're going to move to either the right or the left. So f of x minus c will cause the graph to shift c units to the right. F of x plus c causes the graph to shift c units to the left. It's kind of counterintuitive of how you think it should be. So let me write this down, changing the input values will cause function to move left or right along the x-axis. In our other examples, we were moving up and down the y-axis. And these examples will be moving left or right along the x-axis. So in example 3, we have our parent function graphed, f of x, and our new function is g of x is equal to f of x minus 3. What I want you to notice is this x minus 3 is in parentheses. It does not look, let me show you the difference. If I had this f of x and then minus 3, that would move down the y-intercept because the minus 3 is not inside the parenthesis. But once you put it inside the parenthesis, that means you're either going to be moving left or right. And according to our chart up above, f of x minus c will cause the graph to move to the right 3 units. So this will be shifted to the right 3. So what that means, if you have, let's plot some original points on your parent function here. I'll just use this one, and this one. Again, I only need 3. All right, I want to take each one of those and shift them to the right 3. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. Each point will shift to the right 3, and they wanted us to label this g of x. Now we're going to graph a new function. H of x is equal to f of x plus 4. So this graph will shift left 4 units. So let me change to a different color here. So now I'm going back to these blue points. I want to shift each one of them left 4 units. So I'll take my bottom point, 1, 2, 3, 4. I'll take the intercept, 1, 2, 3, 4, move it left 4, and then 1, 2, 3, 4. Each point shifted to the left 4 units, and we're labeling this line h of x. All right, example 4. 2 students horizontally, that's very important that it said horizontally. If they're shifting a function horizontally, that means they can only move left or right. They can't move up or down the function, okay? As shown below, use the graph to answer the questions. So in question A, it says Ryan graphed g of x equals f of x minus 4. This means that Ryan's graph will shift 4 units to the right. Remember, it's counterintuitive. Minus 4, right 4. Label Ryan's graph. So you have to look at those lines and see which, I would kind of look at the y-intercept of the parent function. Which one of those graphs did the x-intercept move to the right 4? Well, I think you can see 1, 2, 3, 4. Change colors here. That this graph is moved to the right 4. That means this graph is g of x. Okay. Cameron graphed the second line. Label Cameron's line H and fill in the blank to represent Cameron's line. So here's h of x. Oh, let me change color here. Let's see. I'll change to red. So here's Cameron's graph, h of x. So Cameron's graph shifted blank units to the blank. So what I want to do is count, go from your parent function. Your parent function goes through 0, 0, and count to the left. 1, 2, 3, 4, 5, 6, 7, 8. So his graph moved 8 units to the left. So if I wanted to write a function rule to describe Cameron's graph, I would say h of x is equal to f of x plus 8, because x plus 8 moves to the left. So you would not want to write it like this. Let me show you what would be incorrect. If I were to write this, h of x equals f of x minus 8, that would move down 8. That plus 8 must be in the parenthesis. Okay. Example 5. The parent function f was shifted horizontally. Now this word is very important because that means it can only move left or right. To create function g, write a function to represent g. So function g shifted blank units to the blank. So here's our parent function. To get to the x-intercept on g, I would have to go 1, 2 units to the left. So to write a function rule in terms of f of x, I would say g of x is equal to f of x plus 2, because we move 2 to the left. All right, example 6. The parent function f was shifted vertically. Now, that's very important, that word vertically, because that means it can either move up or down. To create a function h, write a function to represent h. So here is our parent function, and it shifted down 1, 2, 3 units. So h shifted 3 units down. Now we're going to write an equation for function h. So I'll say h of x equals. Now this time I don't want to put that 3 inside the parenthesis. It needs to be on the outside because it's moving vertically. So I'll say f of x minus 3. That's how we know that it shifted down versus shifting to the right. Okay? And that concludes today's lesson, part 1 of linear transformations.